The following is the readings associated with the second lecture in the Introduction to CS and Programming Using Python course from the MIT opencourseware 6.100L. 2.3 Branching Programs. The kinds of computations we have been looking at so far are called straight-line programs. They execute one statement after another in the order in which they appear and stop when they run out of statements. The kinds of computations we can describe with straight-line programs are not very interesting. In fact, they're downright boring. Branching programs are more interesting. The simplest branching statement is a conditional. As shown in the box in Figure 2-5, a conditional statement has three parts. A test, that is, an expression that evaluates to either true or false. A block of code that is executed if the test evaluates to true. And an optional block of code that is executed if the test evaluates to false. After a conditional statement is executed, execution resumes at the code following the statement. So here in Figure 2-5 is a flowchart for conditional statement. It's a code. At some point in the code, there is a test. If it evaluates to true, it executes the true block. If it evaluates to false, it executes the false block. It branches. But after either one, it will return back to the trunk of the tree, as it were. Now in Python, a conditional statement has the form if Boolean expression, then block of code, right? Else block of code. If this evaluates to true, this block of code gets run, or else, that is, if it turns out to be false, block of code. Or you could just have if this thing is true, then run this block of code. Depends on the situation. In describing the form of Python statements, we use italics to identify the kinds of code that could occur at that point in a program. For example, Boolean expression indicates that any expression that evaluates to true or false can follow the reserved word if, and block of code indicates that any sequence of Python statements can follow else. Consider the following program that prints even if the value of the variable x is even and odd otherwise. If x modulo 2 equals 0, which means if x divided by 2 returns a remainder of 0, meaning it's even, execute this block of code, the print function with the string even passed in as argument. Else, if it doesn't evaluate to true, run the print function with the string odd passed in as argument. After this, in a new line, print either way, it will print done with conditional. The expression x modulo 2 equals 0 evaluates to true when the remainder of x divided by 2 is 0 and false otherwise. Remember that equal is used for comparison, since equal is reserved for assignment. Indentation is semantically meaningful in Python. For example, if the last statement in the above code were indented, if this print was aligned vertically with this print, it would be part of this. That's why it's on a new line unindented, it will execute outside of that if statement. It would be part of the block of code associated with the else, rather than the block of code following the conditional statement. Python is unusual in using indentation this way. Most other programming languages use bracketing symbols to delineate blocks of code, e.g. C encloses blocks in set braces, also known as curly braces and curly brackets. An advantage of the Python approach is that it ensures that the visual structure of a program is an accurate representation of its semantic structure. because indentation is semantically important, the notion of a line is also important. A line of code that is too long to read easily can be broken into multiple lines on the screen by ending each line on the screen, other than the last one, with a backslash. For example, say we have a variable x and we want to assign to it the value that is the result of the expression this huge number plus this huge number plus this huge number. That typing out this whole expression will take up multiple lines, and so they need to use a backslash there to keep it from getting confused. Long lines can also be wrapped using Python's implied line continuation. This is done with bracketing, i.e. parentheses, square brackets, and curly braces. For example, if it was written like this will be interpreted as two lines, and therefore produces an unexpected indent syntax error. Whereas, if we just wrap it all up in the hug of a parentheses, that's interpreted as a single continuous line because of the parentheses. Many Python programmers prefer using implied line continuations to using a backslash. Most commonly, programmers break long lines at commas or operators. You can do whatever you want, man. It's a free country. Returning to conditionals when either the true block or the false block of a conditional contains another conditional, the conditional statements are said to be nested. The following code contains nested conditionals in both branches of the top-level if statement. So, check if x modulo 2 is equal to 0. If it is, see this indented, then we run this block of code, and this block of code is check if x modulo 3 is equal to 0. And then if it is, if that is also true, then print divisible by 2 and 3. This block will only be executed if this check and this check has been passed, right? Or else, print divisible by 2 and not by 3, because that's, and this is, you see by the indentation of where it's aligned, that this runs if this is passed, but if this isn't passed, else print divisible by 2 and not by 3. Else if x modulo 3 is equal to 0, print divisible by 3 and not by 2. So this will run if it checks this and it's not, it doesn't pass, it's not, x modulo 2 is not equal to 0, all of this will be skipped and it'll hit the elif statement, and just, this is a separate check to see if it's x modulo 3 is equal to 0. And if so, you see, by so doing we can clarify things. The elif in the above code stands for else if. It is often convenient to use a compound Boolean expression in the test of a conditional. For example, if x is less than y and x is less than z, and print the string x is least. Else if, elif, y is less than z, print y is least. Or else, finally, print z is least. If none of these checks pass, then of course z would be least. Finger exercise. Write a program that examines 3 variables, x, y, and z, and prints the largest odd number among them. If none of them are odd, it should print the smallest value of the 3. You can attack this exercise in a number of ways. There are 8 separate cases to consider. They are all odd. 1 case. Exactly 2 of them are odd. 3 cases. Exactly 1 of them is odd. 3 cases. Or none of them is odd. 1 case. So, the simple solution would involve a sequence of 8 if statements, each with a single print statement. You just check if x modulo 2 is not equal to 0, and y modulo 2 is not equal to 0, and z modulo 2 is not equal to 0, then print the result of passing in x, y, and z to the max function. If you want to pause and just read through that, but it's not really necessary. It's really just proving a point here. This would get the job done, but clearly it is rather cumbersome, and if you were dealing with any more than just a few things, it would be ridiculous. Not only is it 16 lines of code, but the variables are repeatedly tested for oddness. The following code is both more elegant and more efficient. We create a variable answer, and we set it equal to the result of passing in our three variables x, y, z as arguments to the min function, which will tell us the minimum or something, right? Then, if x modulo 2 does not equal 0, then our variable answer is updated to the value of our variable x. If y modulo 2 does not equal 0, and y is greater than our variable answer, then we update the value of the variable answer equal to the value of the variable y. If z modulo 2 does not equal 0 and z is greater than answer, then answer shall be assigned the value z. Finally, print our variable answer, whatever value it has ended up with after all these checks have been completed. The code is based on a common programming paradigm. It starts by assigning a provisional value to a variable, answer, updating it when appropriate. Wait a second. I just noticed that the few top lines of the page were not showing up in the screen share. I'm very sorry if that screwed things up for anybody, but probably not, because nobody's going to watch this. Updating it when appropriate, and then printing the final value of the variable. Notice that it tests whether each variable is odd exactly once, and contains only a single print statement. This code is pretty much as well as we can do, since any correct program must check each variable for oddness and compare the values of the odd variables to find the largest of them. Python supports conditional expressions as well as conditional statements. Conditional expressions are of the form expression 1 will be completed if condition is met, else expression 2 will be evaluated. If the condition evaluates to true, the value of the entire expression is expression 1. Otherwise, it is expression 2. For example, the statement x equals y, x set equal to y, if y greater than z is true, else z, sets x to the maximum of y and z. Whichever one is bigger will end up assigned to the variable x, because this check is completed, right? A conditional expression can appear any place an ordinary expression can appear. I'm just making sure that's still on the screen, yeah. Including within conditional expressions. So, for example, the print function with passed in as argument this crazy thing, first parenthetical statement, x if x greater than 0, else z, or x greater than z, else z, if x greater than y, else this whole thing, y if y greater than z, else z. This will print the maximum of x, y, and z. I might pause and look over that more carefully if that didn't make sense, but don't worry still if you're confused. Conditionals allow us to write programs that are more interesting than straight-line programs. But the class of branching programs is still quite limited. One way to think about the power of a class of programs is in terms of how long they can take to run. Assume that each line of code takes 1 unit of time to execute. If a straight line program has n lines of code, it will take n units of time to run. I have a chord in front of the screen. What about a branching program with n lines of code? It might take less than n units of time to run, but it cannot take more, since each line of code is executed at most once. A program for which the maximum running time is bounded by the length of the program is said to run in constant time. This does not mean that each time the program is run it executes the same number of steps. It means that there exists a constant, let's call it k, such that the program is guaranteed to take no more than k steps to run. This implies that the running time does not grow with the size of the input to the program. Constant time programs are limited in what they can do. Consider writing a program to tally the votes in an election. It would be truly surprising if one could write a program that could do this in a time that was independent of the number of votes cast. In fact, it is impossible to do so. The study of the intrinsic difficulty of problems is the topic of computational complexity. We will return to this topic several times in this book. Fortunately, we need only one more programming language construct, iteration, to allow us to write programs of arbitrary complexity. We get to that in section 2.5. Stay tuned. Hold up, what? Alright, 2.4, this is the last section for this reading for the second lecture. Strings and input. Objects of type str, string, are used to represent characters, as in alphanumeric characters. Literals of type string can be written using either single or double quotes, such as ABC with single quotes around it, or ABC with full quotation marks around it. Makes no difference as long as it's the same one on each side. The literal apostrophe 1, 2, 3 apostrophe denotes a string of 3 characters, not the number 1, 2, 3 or 123. This isn't an integer type. Try typing the following expressions into the Python interpreter. If you do this, you will learn some things. Type this in and press enter, type this in and press enter. The operator plus sign is said to be overloaded because it has different meanings depending upon the types of the objects to which it is applied. For example, the operator the plus sign means addition when applied to 2 numbers, and concatenation when applied to 2 strings. Concatenation means literally like chaining together, catenare, con, and that's when you chain strings together as concatenation. It's not the same as addition. The operator star is also overloaded. It means what you expect it to mean when its operands are both numbers. When applied to an int and a string, it is a repetition operator. The expression in star s, where in is an integer and s is a string, evaluates to a string with in repeats of s. For example, the expression to star the string John, remember the quotes, has the value John John. It will return a string which is just this string repeated 2 times, John John. There is a logic to this. Just as the mathematical expression 3 times 2 is equivalent to 2 plus 2 plus 2, the expression 3 times a string is equivalent to the string concatenated with the string concatenated with the string. Now try typing new underscore ID and then the string A star the string A. Now, each of these lines will produce an error message. If you type this and press enter, then type this and press enter, you'll just get error messages. The first line produces the message name error, and it will tell you that this name, new underscore ID, is not defined. Because it's like you try to name a variable, but you didn't assign a value to it. Because new underscore ID is not a literal of any type, the interpreter treats it as a name of a new variable. However, since that name is not bound to any object, attempting to use it causes a runtime error. The code string A times string A produces the error message type error, because you cannot multiply sequence by non-int of type string. You can't multiply one string by another. The fact that type checking exists is a good thing. It turns careless and sometimes subtle mistakes into errors that stop execution, rather than errors that lead programs to behave in mysterious ways. The type checking in Python is not as strong as in some other programming languages, such as in Java, but it is better in Python 3 than in Python 2. For example, it is clear what the left-pointing chevron, the less than sign, should mean when it is used to compare two strings or two numbers. But what should the value of the string for is less than the integer 3 be? What the hell does that mean? Rather arbitrarily, the designers of Python 2 decided that it should be false, because all numeric values should be less than all values of type string. The designers of Python 3 and most other modern languages decided that since such expressions don't have an obvious meaning, they should just generate an error message. Strings are one of several sequence types in Python. They share the following operations with all sequence types. The length of a string can be found using the len function. For example, the value of len with the string ABC passed in is 3 because it is 3 characters long. Indexing can be used to extract individual characters from a string. In Python, all indexing is zero-based. It starts counting upward from 0, not 1. For example, typing the string ABC followed immediately by in square brackets the number 0 into the interpreter will cause it to display just the string, the single letter A, because it's saying, find me the thing at index 0 of the string ABC. Since it's 0 indexed and starts counting at 0, we'll find here the first character is returned. Okay. Typing ABC at index 3 will produce the error message index error, string index out of range, because again, starting at 0, 0, 1, 2. There is nothing there at index 3. Since Python uses 0 to indicate the first element of a string, the last element of a string of length 3 is accessed using the index 2. Negative numbers are used to index from the end of a string in reverse. For example, the value of the string ABC at index -1 is C. Just the whatever is the very last thing will be indexed. It can be accessed by -1. Slicing is used to extract substrings of arbitrary length. If S is a string, the expression S start : end denotes the substring of S that starts at index start and ends at index end, -1. And this is not, you wouldn't actually type out start and end, it's just, okay. For example, string ABC, and in square brackets immediately following it, 1:3 evaluates to BC, because it returns a slice of that string, which starts at and includes what is at index 1, which is B, and goes up to but does not include what is at index 3, which, since there's nothing there, it's just BC. Now, why does it end at index end -1 rather than end? So that expressions such as ABC, the slice going from 0 to the length of ABC, have the value you might expect. Think about this for a little second, because it's okay again if you're a little bit confused, because the string, the length of it, what is returned whenever you pass in a string as argument to the length function, will give you 3 characters in this case. The length of it is 3, but of course there is nothing at index 3 because the indexes start counting at 0. But if the value before the colon is omitted, it defaults to 0. If the value after the colon is omitted, it defaults to the length of the string. Consequently, the expression ABC with, in square brackets, just a colon is semantically equivalent to the more verbose a string ABC with a slice from 0, index 0, to the length of ABC. It is just, this is a slice that contains the whole thing. Like if you give me one particularly big slice of that cake, where you just cut on either side of the cake and just take it all and say I just had a really big slice. It is also possible to supply a third argument to select a non-contiguous slice of a string. For example, the value of the expression, here's this long string, 1, 2, 3, 4, 5, 6, 7, 8, 9, followed immediately by, in square brackets, 0, 8, 2, is the string 1357. Because this is a slice from 0, including, up to but not including 8, with an increment of 2 that will step 2 steps instead of 1 at a time. So it'll get 1, and then 2 steps over, get 3, 2 steps over, get 5, 2 steps over, 7. Begin, end, step, or increment. It is often convenient to convert objects of other types to strings using the string function. Consider, for example, the code. Num set equal to this, which I can't read easily because there's no commas, fraction, the variable fraction set equal to 1 divided by 2, and then the print function called with the arguments num times fraction, comma, the string is, comma, space, that variable fraction times 100, comma, space, then the string, the percentage sign, comma, space, the string of, comma, space, and then finally the variable num. And something very similar, except with fraction times 100 passed in as an argument to the string function, so that it will get this back in the form of a string. And this will print two very similar things, except we will get, yeah, I mean, it's, you got it, because you can concatenate strings. Now that you've passed this into the string function and gotten back this but in string form, then using the plus sign operator will you can chain it together with another string. So you'll get it right up against the 50. The first print statement inserts a space between 50 and the percentage sign because Python automatically inserts a space between the arguments passed into print. The second print statement produces a more appropriate output by combining the 50 and the percentage sign into a single argument of type string because they're concatenated together. Type conversions, also called type casts, are used often in Python code. We use the name of a type to convert values to that type. So, for example, the value of integer, the int function, with the string 3 passed in, times 4, is 12. It will convert our string 3 into an integer, and then multiply it by the integer 4. So we will get an integer. When a float is converted to an int, the number is truncated, not rounded. So, for instance, the value of the float 3.9 passed into the integer function will just get the integer 3. It won't be rounded to 4. It just truncates, just cuts it off. Returning to the output of our print statements, you might be wondering about that 0 at the end of the first number printed. That appears because 1 over 2 is a floating point number, because division will always return a float, even though these two things are integers. In Python, the division will always return a float. The product of an int and a float is a float. It can be avoided by converting num times fraction to an integer. So the code, similar to above, except where first the num times fraction is passed in as an argument to the int function, and that's all one single argument thing, among many passed into the print function. This will print this. Python 3.6 introduced an alternative, more compact way to build string expressions. An F string consists of the character F, or capital F, followed by a special kind of string literal called a formatted string literal. Formatted string literals, f-strings, contain both sequences of characters, like other string literals, and expressions bracketed by curly braces. These expressions, the ones bracketed by curly braces, are evaluated at runtime and automatically converted to strings. So, if we print the F string, the F just smushed up against the beginning of a string, then everything that is inside curly braces gets evaluated at runtime, and it won't print, int num times fraction. It will print the result of evaluating this and the result of evaluating this. And so it'll produce the exact same output as the previous more verbose print statement. If you want to include a curly brace in the string denoted by an F string, just use 2 in a row, and then that curly brace will actually show up in the printed output. So printing the F string, curly brace, curly brace, curly brace, 3 times 5, curly brace, curly brace, curly brace, this will print the result of evaluating this, and these will disappear, but it will actually, the printed output will contain curly braces. The expression inside an F string can contain modifiers that control the appearance of the output string. These modifiers are separated from the expression denoting the value to be modified by a colon. For example, the F string and in curly braces 3.14159 colon point 2f evaluates to the string 3.14 because the modifier point 2f instructs Python to truncate the string up to the, up to the second, to 2 digits after the decimal point. And the statement, the print function with an F string passed in with these replacement fields, num times fraction, colon, comma, period, 0f, and we'll just start with there. This will print 15 million with these helpful commas. Is 50.0% of 30 million, again, with the helpful commas, because the comma modifier instructs Python to use commas as thousands separators. We will introduce other modifiers as convenient later in the book. Input. Python 3 has a function, input, that can be used to get input directly from a user. The input function takes a string as an argument and displays it as a prompt in the shell. The function then waits for the user to type something and press the enter key. The line typed by the user is treated as a string, whether it's numbers or not, and becomes the value returned by the function. So executing a code like we've got a variable name set equal to input with the string enter your name passed in as argument. This will display the line enter your name on the console, in the console window, and then if you then type George Washington or whatever and press enter, then it's that string George Washington will be assigned to the variable name. This is saying, assign to the variable name the result or the output of the input function with the string passed in. If you then execute print the string are you really, comma, the variable name, comma, the string question mark, the line will say are you really George Washington, because the value of our variable name has been assigned to the output of this, right? Notice that the print statement introduces a space before the question mark. It does this because when print is given multiple arguments, it places a space between the values associated with the arguments. The space could be avoided by executing print are you really in space plus name plus the string, because since our variable name has been assigned a string, a value of a string type, then we can concatenate them with these other strings. Or print and then make it an F string, in which we have a replacement field which will be formatted with the value of the variable name. each of which produces a single string and passes that string as the only argument to print. Now consider the code. In equals input with the string enter and int passed in this argument, followed by the print function with passed in this argument the result of passing in the variable in to the type function. Okay, that this will first evaluate this, what is the type of in, and then whatever the result of that is will be passed in to print. And so this code will always print class string, because input always returns an object of type string, even if the user has entered something that looks like an integer. For example, if the user had entered 3 and pressed enter, in would be bound to the string 3, not the int 3. So the value of the expression in times 4 would be the string 3 repeated 4 times, 3, 3, 3, 3, 3, 3, 3, 3, 3, rather than 12, the integer 3 multiplied by the integer 4. The good news is that whenever a string is a valid literal of some type, a type conversion can be applied to it. Finger exercise. Write code that asks the user to enter their birthday in the form month / day / year, and then prints a string of the form you were born in the year y. A digression about character encoding. For many years, most programming languages used a standard called ASCII for the internal representation of characters. This standard included 128 characters, plenty for representing the usual set of characters appearing in English language text, but not enough to cover the characters and accents appearing in all of the world's languages. So the Unicode standard is a character coding system designed to support the digital processing and display of the written texts of all languages. The standard contains more than 120,000 characters, covering 129 modern and historic scripts and multiple symbol sets. The Unicode standard can be implemented using different internal character encodings. You can tell Python which encoding to use by inserting a comment of the form hash space dash star dash space coding colon space encoding name space dash star dash as the first or second line of your program. For example, if you wanted to encode in UTF-8, it would look like this. And this would instruct Python to use UTF-8, the most frequently used character encoding for web pages. If you don't have such a comment in your program, most Python implementations will default to UTF-8. When using UTF-8, you can, text editor permitting, directly enter code like this that involves accents or characters not found in English, and it will print it accurately. You might be wondering how I managed to type the string. Unfortunately, I don't speak or read this language. I didn't. Because most of the web uses UTF-8, I was able to cut the string from a web page and pass it directly into my program. There are ways to directly enter Unicode characters from a keyboard, but unless you have a special keyboard, they're all rather cumbersome. Well done, that's the reading for Lecture 2. In the bag.